This conference
Let's
will
move
now be
ahead.
recorded.
When it comes to storage, there are two basic fundamentals that you have to remember. One is the IOPS and then the bandwidth. There is an important correlation between the IOPS and the bandwidth. So every storage, regardless of whether if it is a hard disk or magnetic storage, or it can be even an SSD storage. So whatever it is, every storage technology out there comes with two limitations. Two limitations are two thresholds. One is IOPS and the another one is bandwidth. So everything has a limit on, every storage technology has a limit on the available amount of IOPS that it can provide or the amount of bandwidth it does provide. So hard disks tend to have lower IOPS. Hard disks tend to have lower IOPS and marginal or average bandwidth. So let's look at a normal example wherein you have 15K RPM SAS disks attached to your rack servers or whatever the storage servers, whatever you are using. Typically, if you are using a magnetic storage, then magnetic storage in the sense hard disk, you typically use 15K RPM disks. These usually come with a threshold of somewhere close to 400 to 1200 IOPS per second. And the bandwidth, these days they have even increased to 200 or even 400 MB per second. So you have to remember that there is an important correlation between these two. So OLTP databases usually make small IOs. Your index scan, joins, redo writes, whatever it is, you will be writing small IOs only. You will be either reading or writing small IOs only, which is equal to the size of the database block size. So database block size. So suppose if I have a database with a block size of 8 KB, I have a limitation here from the storage layer regarding saying that I cannot exceed beyond 1200 IOPS. In this case, I can read only 1200 blocks that are present at various locations, or even sequentially as well. If you are making several sequential IO requests as well, you cannot exceed this threshold. If you are pushing more load, then basically what happens is that you hit the threshold on the IOPS. You basically hit the threshold on the IOPS and your request gets queued. Subsequently, due to this, the average wait times tends to increase. So you need to remember that. So translating this 1200 IOPS into 8 KB. So block size on an average, you can read close to 9.4 MB per second only. The bandwidth utilization will be only 9.4 MB per second, but due to the fact that you are making small IO requests, which is of the size 8 KB, you are more likely to saturate IOPS at the storage layer. Once you hit the IOPS at the storage layer, once you hit the cap on the IOPS of the storage layer, your average wait times tends to increase. So if your disk utilization, also you have to remember that once you hit the cap, your disk utilization rate hits 100%. So you have to remember, if you are pushing more load than the thresholds, your average wait times increases. So looking at an AWR report or $V system event or any other views, and then if you look at average wait times, if they are beyond 10 milliseconds or 20 milliseconds, if you think that there is a storage issue, then you are basically going in a wrong path. It could be due to the fact that one of the SQL statement might have flipped the plan and it is causing more IO than necessary, which is basically saturating the IOPS at the storage layer. So you need to remember that first check the workload at the database layer. First check the workload at the database layer. See if there is any activity which is consuming more IOPS, which is reading more blocks than necessary. Any unusual activity, until you do that, do not go to the storage teams. Do not go to the storage team. Storage team, you will end up raising a ticket or a service request with the storage team, and eventually these guys will come back saying that everything is basically fine. So you need to understand this particular relationship. So when you are performing full table scans, you are more likely, it's not more likely, depending upon the DB file multi-block read count, you will read multiple blocks that are stored in adjacent locations in a single IO request, thereby making a large IO. Suppose say if your multi-block read count is 128, you end up reading 128 blocks. Suppose if my database block size is 8 KB, I would end up reading close to 1 MB in size. So one IO request of 1 MB, if my storage gives me 1200 IOPS and the bandwidth is only 400 Mbps, I can at a maximum, once I hit 400 to 450 IOPS, since I'm making large IOs, I am more likely to hit the threshold on maximum bandwidth available. So you need to understand this particular fundamental. So when it comes to OLTP databases, you are more likely to saturate IOPS at the storage layer. When it comes to the OLAP or even reporting or warehouses, where you have mostly full table scans or even hash joins, you are more likely to saturate bandwidth at the storage layer. So guys, you need to understand another basic fundamental. One moment, please. You need to understand a very basic fundamental. So tomorrow, if you are in a position to, if you are asked to, or if you have been tasked to design a particular database, always prefer solid state disks. These provide high IOPS and bandwidth as well. Magnetic storage is pretty dumb. These provide you very less IOPS. So for OLTP databases, do not prefer magnetic storage. Always go with the SSDs. SSDs give you more IOPS. You are very less likely to saturate IOPS at the storage layer once you use SSDs. There is a perfect balance between the IOPS and the bandwidth when it comes to SSDs. The reason why hard disks give you less IOPS is due to the fact that this is the spindle, guys. It rotates at, suppose say 15K RPM or 15,000 RPM per minute, rotations per minute. This is what you call the read or write head. Read or write head. Suppose if the blocks are located at various locations, your read write head has to move from this location to another location. This takes time. This takes time, and not only time, but also you have to remember that since the disk is spinning, what if the block that you want to read is present here? You need to wait until the disk rotates till here. So due to the fact that you have a moving parts that relates to both the disk and the read write head, your average wait time or average time to read a particular block will be a bit high. Usually they will be in the order of milliseconds. When it comes to SSDs, the average wait time to access a particular block is very less. It will be in the order of microseconds, not milliseconds. So you need to understand this particular fundamental. So moving ahead. Now you need to understand that once you hit any of these thresholds, IOPS of the bandwidth, your average wait times increases and the subsequent request gets queued. High average wait time does not necessarily mean you have an IO issue at hand. You need to remember that OLTP databases are 99.99% of the time they make small IOs only. OLTP databases, much of your workload is basically index related probe or basically nested loop joins only. So due to the fact that you are doing index probes and nested loop joins, you are most likely to make only small IOs until unless your query runs a full table scan. You need to understand that you are more likely to consume IOPS at the storage layer, and moreover, log writer, even whenever you commit, log writer basically writes the contents of your redo buffer to the redo logs. So you need to remember this as well. These are very small writes. The block size, redo log block size is 512 bytes. These days, this is equivalent to the sector size. These days, the storage providers can provide up to 4 KB as well, but this can result in more redo wastage, which is unnecessary. So we'll talk about this more about this when we are dealing with log file sync and all those waiting. So for now, the basic fundamental, you need to understand that OLTP databases, you are more likely to issue more, small IOs only. You are more likely to saturate IOPS at the storage layer. When it comes to the warehouses, due to the fact that you are running full table scans and hash joins, all those things, so you are more likely to consume the bandwidth at the storage layer, not the IOPS, but the bandwidth. Remember, hard disks have very few IOPS, but marginal bandwidth, not enough bandwidth, marginal bandwidth only. SSDs give you a better balance between IOPS and the bandwidth because they have very high IOPS. Even a small SSD that you buy in the market right now for 3,000 or 2,000 rupees will give you 35,000 IOPS for 35,000 IOPS. Now consider enterprise grade SSDs. They are more. They will give you even more than 100K IOPS. Nowadays, the storage technology has evolved to an extent that NVMe storage, which runs on PCI Express lanes, can give you even 1 million IOPS. So you need to understand that particular thing. So let's proceed ahead. With the basic fundamentals for any database, the first thing you need to know is how does a session or your server process performs a full table scan. So when you look at from the storage perspective, full table scans, you end up reading the entire segment. So from Oracle end, these are all the 6 factors that, I mean, indirectly I would put it as 4 factors that influence the cost decision. Optimizers cost, I mean, these influences the optimizer cost. These 4 parameters will influence the performance. I mean, you can perform a full table scan using either a scattered read or a direct path read. So this decision is dependent upon various thresholds. So we'll talk in depth regarding all of these in the coming sessions. I mean, not sessions, today itself. If you would like to, if you have time to cover everything. So basic thing you need to remember that all these are interlinked with one another. It's not just reading the table. It's not as simple as just starting reading the table from the initial extent till the last extent. There are too many issues that can come up. You need to basically understand what all factors can contribute to the cost, optimizer's cost, what all factors can influence the performance of your full table scan, what all factors can result in increased number of block reads, and what all factors will contribute to your DB file scattered read or direct path read decision. So even before proceeding ahead with the full table scan, you need to understand basic concepts regarding a segment. What is a segment? Anything that occupies space in a database is called as a segment. Segment header. For every segment, there is something called as the segment header. You can get the block details. I mean the block which contains the segment header from DBA segments view. You have something called a header file, a header block. So you can get the details regarding a segment header here. So till now, guys, do you have any doubts?
Hey, Vishnu.
Yes.
Hi. One example you showed in the first slide for the IO ops, you mentioned that okay, when we hit the threshold on IO ops, it'll start showing the 100% disk usage. So you
Yes.
took the one random example of 1200 IOPS and you multiplied or added with the block size. So can you just repeat that part small? How you come up that value, the limit value, the threshold value, with any example like 1200 IOPS and 8 KB block size?
8 KB block size is your default block size.
Right.
So 1200 IOPS is a random example that I took.
Correct.
Usually the hard disk, it will be even way less.
Right.
It
But you
will be less.
mentioned that okay, the threshold, you showed the threshold. If let's take example 1200 IOPS and 8 KB block size. So what would be the threshold when IOPS will saturate it?
So once you read 1200, once you initiate 200 IO requests per second, your bandwidth is saturated. Your IOPS is saturated.
Okay.
You get it, right? So
Yeah, I get it.
if you have multiple sessions performing an index range scan, so index range scan is basically what? You read the root block, branch block, leaf block, and you have the index row IDs, right?
Right.
Each row ID, suppose say it points to different table block. Suppose if a SQL statement ends up reading 100 blocks which are stored at different locations. In this case, 10 sessions or 20 sessions executing the same SQL statement, reading multiple blocks which are stored at different locations is enough to saturate your IOPS of the storage layer.
Okay.
Is more than enough to saturate the IOPS of the storage layer. So right now, as of now, I'm building a virtual machine as we speak. on an ESXi host, probably by the, we still have 4 hours left. By the time it is finished, probably in 15-20 minutes, I can show you precisely how this thing happens. So that's the reason why I haven't shown a demo now. So
Okay.
wait. Please hold on for the next 15 minutes because I'm actually provisioning an ESXi host as we speak. So in a virtual machine, the problem with a virtual machine tier 2 hypervisor is basically that. And another thing you need to understand, in your virtual machine, you don't know where you are basically. See, your virtual machine, whatever you're using, either it is a VMware workstation or Oracle VirtualBox. These are basically tier 2 hypervisors. So every IO request or whatever the CPU related call, whatever it is, whatever you make will be handed over to the operating system first, and then the hardware usually processes it. So here there is a high chance that the operating system can end up catching the blocks, wherein you do not see the actual results. So the best way to look at this behavior is to use a tier 1 hypervisor, which can directly access, which lets your VMs directly access the hardware. So what I'm going to do now is I'm going to provision a machine now, a database, and then basically, so I have provisioned a machine here. So probably, I still don't have a database here. Once that is done, I'll show you the relationship between how the IOPS and the bandwidth more precisely, so that you get to see the details. In the morning session, what I did was I basically used a virtual machine from VMware Fusion. So the example was good enough, but it was not able to show to depict the true behavior. Anyhow, I'll show it right now. So what I'm going to do now is on this particular database. So let me do one thing. I'm going to reset any hidden parameters if I have used. Once it is done, I'll start loading the data into the table and then start the workload. So the program is basically, I'll be using a Java program. So honestly speaking, loading the data using SQL plus utility is more of a nonsense kind of thing, because the reason why I call it nonsense is you cannot truly exploit or see the behavior of ASSM kicking in and everything. So we'll talk about that soon. So now it is started. Now I'm going to load some data into the table. So I've started running it. Let it load some data. It is loading the data into this students table right now. Let it increase. So it's now, let it increase till probably 1.2 gigabytes or something like that. So the reason I am setting the file system IO options to set all is I don't want the operating system buffers, operating system file system buffers to start caching the data. So I think it is more than enough. So the student's table is more than 1.9 gigabytes, so I'll try to reduce this as well. So once this is done, you would basically see the load coming in. What I'm going to do is I'm going to start with a full table scan against the database. If you can notice, there are no indexes on this particular table. So what I'm going to do now is I'm going to issue a query that basically runs a full table scan against the database. So give me a minute, guys. Yes, it's going to run a full table scan against the database. Load, which basically runs full table scan. So if you notice, all the queries are basically performing a full table scan against the database. So when I'm performing a full table scan, each IO request tends to be huge. So see the aggregate bandwidth that I'm getting out of this, guys. See the IOPS. I am close to consuming 11,000 or 10,000 IO operations per second. See here, I am reading close to 2.6 gigabytes per second. So what I'm going to do now is I'm going to stop the entire load, and instead of performing a full table scan, the next workload, what it's going to do is it is going to run an index range scan. So let me create an index as well. I'm just trying to modify the code so that you get to see the actual details here. So the index is created now. I'm going to execute the workload against the database right now. What is it doing? It is performing an index range scan. Let's look at things from the storage perspective. See here, I am hardly reading 120 MB per second. Previously, I am reading about close to 2.5 gigabytes per second. So here, can you look at the IOPS here? Can you observe the IOPS? And the
Yeah,
average
increased.
and the average wait times as well.
Yep.
Before, when I was performing full table scan, I was basically saturating the bandwidth, even though I was reading close to how much? 2.3 gigabytes in a second. See, the disks were, even though they were 100% utilized, the average response was, can you notice these things? So this is a typical, the problem here is my Mac system is catching all the data here. Can you see 8.3, 8.8 GB cache?
Yep.
The problem is I'm catching more data here. So even though if you can notice the difference itself is very obvious, due to the fact that I was making large IOs, I was saturating the IOPS of the storage layer. When I was performing index range scans, even though I was reading only, even though I am reading, even now I am reading only 120 or 100 MB per second. See the amount of IOPS that I'm consuming. So let me show you, let me show that in another sense. So these many IOPS per second approximately translates to 8 KB. So 115 IOPS, 115 MB per second. So does this translate, Anurag? 115, 200 MB per second. Can you notice the difference here?
Yeah, yep.
So this is how things work. So any other doubts, guys? Hello? Did you understand the relationship between the IOPS and the bandwidth? Guys?
Yep. Yep. Yeah, Vishnu.
So we'll proceed ahead with the concepts regarding a segment. So you need to understand that okay, let me just start where I left off. So evening session, it's very quick. I mean, we have already covered 6 slides. In the morning session, we are only able to cover 20 slides. Yeah, we are proceeding fast. This is good. So every segment has something called as the segment header. You can obtain this segment header block from this particular view. So all you have to, if you have to view a particular segment header, all you have to do is dump this particular block. So usually in an extent, in a table space with auto allocate, extent says auto allocate. One moment, guys. I don't know why the CPU is huge. Okay, let me just stop the workload, whatever I'm running right now. So yeah, they have come now. So in a table space with extent size auto allocate, initial extent allocated is of size 64 KB, and as the segment grows, the extent sizes increase as well, starting from 64 KB, then 1 MB, then 8 MB, and so on. It increases. You don't have to specifically remember these values. These are of no use whatsoever. So the point here is, when you are using auto allocate, the segment header will always be the third block of the first extent allocated to the segment. Suppose if you are using uniform extent allocation, it could be either the fourth block or the fifth block in an extent. How do you find out whether if it is the third block or the fourth block or the fifth block? You have something called as the DBA extents view. So let me just show you that as well. See here, we have something, we have already created a students table. Let me see it, header file, header block from DBA segments, where segment name is equal to students. So the header file is basically 7 and the block is this. So here in another second, what I'm going to do is extend, select file ID, block ID from DBA underscore extends, where segment name is equal to students, and I think this is more than enough. Order by blocks BSC. So here, if you notice, 402418, 4024 order by, let me see, order by block ID. So 402418. So if you notice here, this is precisely the block that I'm actually looking for. This is the first extent allocated to the database. So I don't even have to do these things. You have something called as the extent ID. That should actually give us more details. Order by extent ID DESC. So here you should actually get it. So this is the first extent allocated to the segment. So let me just copy this over here. So these are pretty important, guys. This may sound really, how do I put it? Not important, but it is really important. So header file, header block, and db_segments. So if you notice here, segment header block is always allocated in the first extent. This is the first extent allocated to the segment. It is always the third block, provided that you use auto allocate. So 416, 417, 418. You can call this segment header as L3BMB as well. L3BMB level 3 bitmap blocks. So if by default, all your table spaces are now automatic segment space management. We know that the free space in the table blocks are managed using bitmap blocks. So the segment header is a bitmap block as well. It is also a bitmap block. This resides at the top of the structure. So all the blocks which are allocated before the L3 BMB block are either L2 BMBs or L1 BMB blocks. We'll talk in more depth regarding L1, L2, L3 BMBs in the coming sessions. When we look at the path, insert path, so we'll discuss more insert path and NQHW contention, NQFP contention, all those weight events. We'll look at in depth regarding these bitmap blocks, and we'll also look at the disadvantages posed by ASSM as well. So this is a header block. Header block, you can also call it as the L3 bitmap block. L3 bitmap block or the segment header usually contains the details regarding the high water mark information, extent map as well. Extent map is nothing but information regarding all the extents that are allocated to the segment. So if your segment increases in size beyond a certain threshold, there could be another L3 BMBs also allocated. So you will have the pointers in the segment header block regarding other L3 BMBs as well. So that is not necessary for now due to the for the full table, and moreover troubleshooting or going to this particular level is not required. Just for theory purpose, you can understand that there could be multiple L3 BMB blocks allocated for a segment as well once the table size increases beyond a particular threshold. So this is a pretty basic stuff, guys. So the segment header contains the high water mark information and extent map as well. So when a optimizer, you have to understand that optimizer's duty is to basically come up with a plan itself. Its duty is to come up with a plan, how best I can execute my query. The plan only, it is the session which executes the query. So now let's suppose we take the same query that we executed before, select max of marks from students. So let's take the same query that we executed before, which took a full table scan. So optimizer came up, looked at the query. So you don't have any indexes on this particular query. So basically the obvious solution is to go with the full table scan. The optimizer came up with this particular plan. Yes, now the session has to execute this particular query. So how do I basically, one moment guys, I just lost track, I just got a message. So how does the session even proceeds ahead? Any idea, guys? How does the session know which extents are allocated, where to start with? everything. How does it even know where is the high water mark information, all those things? Guys, any idea? So the
Header block.
session, Ganesh?
Header block, the same block which we are
Yeah.
talking earlier.
Yes, any session which is performing a full table scan starts reading the header block. The first IO that it initiates will be the segment header only, provided that the block is already not in the buffer cache. If the block is not already in the buffer cache, you will notice the entry in the 10046 trace. Otherwise, you will not notice it, because the block might already be present in the buffer cache. You need to remember, this is a very important thing, guys. Whenever you are running a 10046 trace, if the blocks are already cached in the buffer cache, you will not see even a single entry. You will not see even a single entry. All you would basically see is SQL execution and then the plan. That's it. So let me just show you the example here as well. So I have a table here. Select ABG of mark 1 from students where mark 4 is equal to 123. I have executed this query multiple times. Most of the blocks are already cached in the buffer cache. So let me run an SQL trace on the session right now. So I'm going to execute the same query here. Let's observe the SQL trace. What does it contain? So can you see any entry related to reads or anything, guys? Can you notice anything here? You don't find any entries because of the fact that the blocks are already stored in the buffer cache, already present in the buffer cache. So in another session, what I'm going to do is I'm going to flush the buffer cache. I'm going to flush the buffer cache. Now I'm going to execute the same query. So if you notice here, you will see all the entries, because this is due to the fact that I have flushed the buffer cache and I don't have. Once you flush the buffer cache, that particular buffer will be marked as free. We'll talk about more in-depth details regarding the buffer cache in the subsequent sessions. But the basic fundamental you need to remember is, if you have blocks which are already cached, you don't find the details in your SQL trace. The reason why I came up with this particular thing before is, when you are tracing a full table scan session, which is performing a full table scan, the reads, the session accesses the root block first, guys. You may not, if the block is already cached in the buffer cache, you may not find these corresponding details. So you need to remember that particular thing. So what does the segment header contain? So let me just dump the header block. So here I'm dumping the header block here, guys. So where is the header block? So one moment, guys. Header block of students table. Sorry, I have used the wrong command here. So here, this is the segment header. So how did I even, how do you, I mean, you might wonder what the script is. The script is nothing, guys. What it does is, it basically gets the header details from segment header file and header block from DBA segments, and then issues alter system dump data file 7 and whatever the block is, that's it, and then it displays the result here. So it's as simple as that. You don't have to worry how do I dump that particular segment header. So let me take the screenshot of this particular segment header block. So you need to understand one particular important detail when it comes to full table scans. Segment header contains the details regarding high watermark information, and also it contains the details regarding the low high watermark details as well. So there are two high water marks for any table which is stored in ASSM. One is the low high water mark and another one is the high water mark. All the blocks beyond high water mark are unformatted. So you need to remember that basic fundamental as well. See here, guys. This is the high water mark. There are blocks. See the number of blocks. So Oracle, you have to understand one pretty basic fundamental here. All the blocks. So let me just give you the details regarding the high water mark as well. I'll just paste it here. So in any segment, the blocks below the low high water mark are known to be formatted, and they may contain or may not contain data. So if you are deleting the data from a block, it may become empty. So below the low high water mark, all the blocks are basically formatted. All the blocks are basically formatted. They may contain data or they may not contain data. So if you are deleting, if you have deletes running on the database, you will have blocks which may contain only 50% or 20% used or even 10% used, or if you are deleting all the rows, all the block will be essentially free. So we'll talk about that soon. So now you have to understand that the blocks between the high water mark, low high water mark and high water mark can be either formatted or unformatted. So you need to understand one pretty basic fundamental. When you are inserting a row into the table, the block has to be formatted. The block has to be formatted. If the block is not formatted, Oracle will not allow you to insert. Only if you format the block, Oracle can insert the data into the particular table. This block formatting is done transparently in the background by the session itself. So you need to remember that. And moreover, all the blocks above the high water mark, high water mark are unused and unformatted. So here, these two thresholds are very important. The blocks between these two high water mark positions can be either formatted or not formatted, unformatted. They can be either formatted or unformatted. So the distance between these two will not be that significantly high, guys. You need to remember that. So here, when you are performing a full table scan, the segment starts by reading the segment header block. Here it obtains the details regarding the low high watermark information, high watermark information. See here, this is the extent which contains the high watermark. This is the extent which contains the low high watermark position. So you need to remember that. So and moreover, your segment header also contains the details regarding the extent map. Extent map is nothing but all the extents that are allocated to this particular segment. And you will also have auxiliary map. We will talk about this later on. Right now, this is not important. These L1 DBAs and everything, this is not important for now. We'll talk about it later on. So these two positions are pretty important. Remember, guys, let me just take a fresh screenshot. I mean, things are not working proper now. Let me just take a fresh screenshot here. So here, for estimating the costs and everything, Oracle uses this particular information. Even if you do not have any statistics, dynamic sampling, what it does is it ends up reading this segment header block and obtains the details regarding the high watermark as well. So this is how it obtains how many blocks are even allocated to this segment and everything, how many blocks, what is the position of the high watermark, high watermark, and how many blocks are below the high watermark, everything. It also gets it from this particular location only. This is the actual number of blocks. I mean, for during the cost estimation, optimization, when it is estimating the cost for full table scan, it uses this particular information. It will not use this information. The blocks here, the first line extent header, this line actually displays the details regarding the number of extents allocated to the segment and total sum of blocks for all the extents. So let me just do one thing. So here, the simplest way to explain this more precisely is what I'm going to do is I'm going to allocate an extent to this particular table, guys, order table. So I'll show you in a different sense so that you get more insight as to what I'm talking about, and this forms the fundamental for other sessions as well. So I'm just grouping up by the number of extents, guys. So here we have several extents of size 1 MB, 64 KB, 1 MB, 8 MB, 64 MB, and the last one is of 50 MB. We'll talk about why this extent size is uneven, not now, later on. So now, for now, what I'm going to do is I'm going to allocate an extent to this particular segment is alter table students, allocate extent. So another thing, can I allocate a 5 GB extent, guys? So do you think Oracle, when I issue this particular statement, do you think Oracle assigns a 5 GB extent? Can an extent size be of the size 5 GB?
No, it should be smaller.
Yes, even though you specify very high sizes does not necessarily mean a single extent will be of that size. If you notice here, see, most of the extents allocated are 64 MB in size. Do you get it, guys?
Yep. Yep.
Yeah.
So if your table size is significantly less, suppose say if my table size is only 1 GB and auto increment ensure that it is, I mean, you have to understand one basic fundamental here. Oracle automatically increases your extent sizes, okay, as the table grows. So if my extent, so here you need to understand what, okay, let me just create a different table and then show you the details. So create table 10, okay, drop table 10, create table template, select star from students where Bonum less than, suppose say 8 million, 7 million. So I think this should come up, this should complete soon. So it's going to be reading 63 MB per second. I think it's complete now. So let me see the size. So here, guys, the size is only 560 MB in size. So the size is only 560 MB. So what I'm going to do now is I'll show you the details of the extent. See here, the maximum extent size is only 8 MB. So what I'm going to do is I'm going to allocate many extents here. So I can even allocate 10 GB, 10 GB. I mean the extents are which amount to 10 GB in size. So I have allocated it. So let's see the aggregate of all the extents. See, can you notice here, guys? I think this has been recently fixed because in the Jan PSO or something like that, what happened was when you ran this particular SQL statement, it used to allocate only 8 MB extents. I think the first batch should remember this. I mean, the people from the first batch who have attended, Are you the, I mean, are anyone from the first batch here in this session?
Sorry, Vishnu. Can you
Are there anyone from the first in this session?
Yeah, Pankaj here from first session.
Yes,
No,
Vishnu,
no,
Rakesh.
this is different. I'm not talking about you are all these. I mean, today we have started the second batch. I was talking about the first batch.
Yes, sir. Abhishek here. Yeah.
Yeah, Abhishek, do you notice this? Previously, it used to allocate only 8 MB extents. Now the behavior is changed completely altogether.
Yeah. Do, sir. Yeah.
Yes. So when you are allocating an extent, guys, remember that it will not allocate single 10 GB extent. So that is the point that you have to remember. Now, let me dump the header block of the students table. The point is header block of students more. So here, if you notice, I'm gonna take this thing here, take a screenshot of this here and then show, place it right here. So here guys, if you notice, the blocks below the high water mark hasn't changed. The blocks below the low high water mark hasn't changed. It is only the fact that the number of extents allocated to the segment and also the blocks, total number of blocks to the segment has changed. So the reason for this is, the main reason why I am explaining this is, during a full table scan, Oracle reads only the blocks below the high watermark position. It will not read beyond the high watermark because all the blocks above the high watermark position are basically unformatted. When a block is unformatted, there is no point in reading that particular block. Even though I have close to 900K blocks. So there is no point in reading the data which is not even formatted. So Oracle, so this is a simple example, or this is where, I mean, this is an, if you look at it from a different perspective, even though the student's table is of size 7 gigabytes, a full table scan will end up reading only 2 GB. So I'm going to show you that as well. Select ABG of Mark 1, Mark 3 from students. So I'm going to display the plan. See here, guys, it read only 242K blocks. 242K blocks. See here, guys. This is, you might wonder why it is not 243K blocks. It is due to the fact that there could be several blocks between the high water mark position and the low high water mark position. These blocks can be either formatted or unformatted. So there is no point in reading the unformatted blocks. So this is the first thing you need to remember. Oracle, before performing a full table scan, it basically reads the segment header. Then this segment header block contains the details regarding the low high watermark position and also the high watermark position. It starts reading from it basically starts reading data from the initial extent allocated to the segment. So what I'm going to do now is I'm going to show you the SQL trace as well. Let me just flush the file system buffers. Let me flush everything out, and moreover, I want to flush my Mac. See here, guys, how much data is cached now. See, tier 2 hypervisors are basically this. So when you are practicing on your virtual machines, you may not observe the true details. So because most of your data might be cached in your OS level caches, since these are tier 2 hypervisors. So what I'm going to do now is I'm going to run this particular query. I'm going to run an SQL trace. on this particular session and then show you what precisely happened. So I'm going to run this query now. Can you notice here, guys? See, there is another important aspect that you have to remember. So why do you think Oracle didn't display any? I mean, hardly the table size is close to. I mean, it has read close to 242K, 242K blocks here. So if you notice precisely, how many entries do I have in my SQL trace, guys? Hardly. How many do I have? 1, 2, 3, 4, 5, 6, 7, 8. So can you tell me now, do you think an SQL trace is an effective troubleshooting utility, guys?
Doesn't look like.
It is not, because if your storage is fast enough, it will not even display the details. And moreover, if you see here, it is reading a read of 13 blocks, 28 blocks, 28, 28, 116, 24. Hardly less than 200 blocks or even 150 blocks. Only reads. I am reading close to 242K blocks or 2,42,000 blocks, and I have only the entries that correspond to less than 150K. So you don't even end up seeing all the entries here. So you need to remember that it always starts with the small extent. It always ends up starting the reading the extents in the order they are allocated to the segment. So it starts with the extent ID 0, then it proceeds ahead with all the extent on the other extents. You need to remember this particular fundamental. So now coming back, one moment, guys. You have to remember, guys, all these segment header block, L3 BMB, L1 BMB, L2 BMB, all this stuff is present only in ASSM. You don't find any of these details in MSSM or manual segment space management, wherein the free space is managed using FreeList. You don't have any of these details, and moreover, FreeList is legacy right now. Even Oracle recommends us to use ASSM. So we'll be covering only certain aspects of FreeList when I am dealing with indexes. So that is one thing else, and let's get back to where we were. So where are we? We are in the concept segment header. Segment header, yes, you have seen all the details regarding the high watermark, low high watermark, and then the extent map and everything. And you've also seen the details regarding the high watermark information and everything. So let me just reiterate the final thing here. So remember, the block specified here will not be used by either the optimizer or session when it is reading. These are not the number of blocks returned. So even though the table size is 8 gigabytes, if my high watermark actually points to an extent which is allocated when the table size is only 2 gigabytes, I end up reading only 2 GB. So don't look at the size of the table and automatically assume. So even though this possibility is there, don't assume that the size of the table will be the same amount of data you read from the disk. So the main point why I'm actually saying this is even though it is highly unlikely you end up getting into this particular scenario, you need to, as a performance tuning DBA, you need to basically look for every aspect, look at every aspect. Even if you are reading 2 extra block reads, you need to understand why it is reading 2 extra block reads. Are they necessary? So that is the primary reason why I'm explaining all these things. So full table scan. Let's proceed ahead with the actual details here, how it starts reading the data. So full table scan, you know that it starts with the initial extent and then proceeds ahead. Yes, that is true. you have to remember that it can read only one extent at a time. You can read only one extent at a time. So let me show you this. Due to the fact that my storage is very fast and then my data is already cached, I may not see the details in the trace files, SQL trace files. So what I'm going to do is I'm going to run an strace on the particular session which is performing a full table scan so that I can show you the IO calls precisely. So now what I'm going to do now is I'm going to run an strace on this particular session and then show you the details. So run strace -p. I can now select image of mark 1 from student. So even before executing it, I don't want it to fill up my screen. So I'll redirect all the data to a different, to a text file. I don't want this basically. So it is finished executing it. So let me just show you the details here. So if you notice here, guys, how many blocks did it read here? It read only 128 KB. You have to remember, regardless of, so I just put it in a different sense, it starts by reading from the initial extent. It starts reading in that particular order. It starts reading in that particular order. It starts with the extent which is allocated to the segment first, and then it proceeds in that particular order. So even now here I don't have all the additional details here, so we'll just go with the normal thing. Tomorrow I'll show you more details. So tomorrow or even today in the by the end of the session, okay, I'll do one thing, guys. Let me just flush the everything, flush the file system caches and everything. Give me a minute. Hope you don't mind. In the meanwhile, do you have any other doubts, guys? Hello? Till now, do you have any doubts, guys?
No, good, Vishnu.
So let me just stop the machine. Let me just flush all the cache here, whatever the cache I have. I don't want this interfering here when I'm showing the actual details. So you have to remember one thing, guys. Tier 2 hypervisors are a pain when you are practicing. It can mislead you in various ways. So what I'm trying to do now is I'm just trying to flush everything out. The problem is the system has close to 64 gigabytes of RAM, so it might take a while for this to actually do the thing. So in the meanwhile, let me go ahead and go back to the slide. So you need to remember one thing, guys. It starts reading from the extent which is allocated first. It starts reading the data from the initial extent that is allocated, and then it proceeds ahead. So I think someone has put it. Yeah. Then it proceeds ahead. You have to remember, even though your block size is 128, even though your extent size, suppose if you have an extent size of 48 KB, 48 blocks, sorry guys, if your extent size is of size 48 blocks, 48 into 8 KB. So it's not even allowing me to write anything here. I'm just using my mouse to write. Give me a minute. I think it should actually clean everything out. Give me a minute. I think it should clean everything out. Yeah, I think it is cleaning out. Give me a minute. I think starting tomorrow we'll look at from we'll start looking things from an actual hypervisor, which actually you can see things as they are. So let me just bring up the virtual machine again. So let me just trace that SQL. Once I've got it, I'm just bringing it up. So it's reading. Okay, now let me just create a session now. So what I'm going to do is I'm going to run an SQL trace against this particular session. This is the CID. So select AVG of Mark1 from students. So now, yeah, I think it has read more than enough. So where did it start, guys? It started with the initial extent. Then it proceeded ahead with in the order in which the extents were allocated to the segment. So you need to remember this particular fundamental. So, and moreover, if your extent sizes are small, or you have to, so let me just bring back this particular slide. So, even though if your multi-block read count is set to something is weird with this pen. So I think it's working fine now. So even though, suppose say the extent is of size 48 blocks, and if your DB file multi-block read count value is suppose say 32, you have to remember Oracle can read only during a full table scan, it can read only one extent at a time. So here in one IO operation, it will read close to 32 blocks, and in a subsequent IO request, it will end up reading the remaining 16 blocks. So you might wonder why basically I am making two IOs here when I can read half of the blocks from this extent and subsequently the rest half from a different extent. You need to remember when you are performing a full table scan, the IO that you issue against the storage is a huge IO. Depending upon your DB file multi-block read count, you end up reading multiple blocks in a single IO operation. You will not read each individual block instead. So suppose in your extent, you have blocks which are stored adjacent to one another. Suppose if I'm reading 48 blocks, the starting position, starting offset of the read operation will be this, and the ending offset will be this, somewhere here. So you will end up reading this entire chunk of data in one IO operation only. This will be your starting position and this will be your stopping position. You will not read one block at a time. You need to remember this one, this basic fundamental. You will read this entire chunk in one simple IO operation. Oracle knows that these blocks are stored adjacent to one another physically in an extent, and moreover, extents allocated to the segment can reside at different locations or even in a different data files. So when you are making a large IO request, basically you cannot merge IOs between two extents in a single IO operation. Even though you utilize asynchronous IO, Oracle will not do that. I mean, frankly speaking, that they haven't developed the code yet. Yeah, it will be possible, it is possible, but they haven't developed it. For that too, for IO submit you can do that too for asynchronous IO calls, but for period 64 calls you cannot do that. That's the primary reason. So this is one fundamental that you have to remember. Let me just show you the yesterday's output as well. So for this same session, so previously what I did was I set the SGA target to a very low value. Due to the fact Oracle did reduce the DB file multi-block read count. So let me show you that as well. So SGA is 400 MB due to the fact that my DB file SGA is very small. I mean the buffer cache inherently will be very low due to that particular fact. RP ended up reducing the value of DB file multi-block read count. Now I am increasing the SGA target to 900 MB. So eventually the size, the DB file multi-block read count value also increases constantly. So your parameter DB file multi-block read count. Now the value is 128. So what I'm going to do is I'm going to run an STS utility, run an STS on this particular session, which is performing a full table scan against the students table. So STS -p -o STS.txt. Now what I'm going to do is self-take of smartphone from students. Okay, it's complete. So if you see here, guys, if you notice precisely in this particular session, so I am making use of asynchronous IO calls. Asynchronous IO calls. IO submit is a classic example of an asynchronous IO call. How many blocks I am reading here, guys? I'm making only one large IO operation. This is the IO call. This is the IO call. I'm reading only one. I'm making one large IO. How many bytes I am reading here? I am reading 1 MB of data. 1 MB usually translates to 128 blocks here. So you can calculate that in a different way as well. So I'll show you that as well. So here by 1024 by 1024, basically 1 MB. Bytes, KB, MB. So 1 MB of data you are reading, that is close to 128 blocks you are reading, guys. So this is basically one large IO operation, 128 blocks, since they are stored adjacent to one another. You don't have to read each block. You end up reading this entire chunk in one IO operation itself. This is the reason why I explained initially that full table scans, due to the fact that you use large IO requests, you are more likely to saturate the bandwidth of the storage layer. So you basically, when you are performing a full table scan, regardless of whether you are reading the full table scan using a direct path read or DB file scattered read, you end up making large IOs only. Here IO submit call is a classic indicator. When I'm performing a full table scan, IO submit call is a classic indicator that I am performing the full table scan using direct path read. So when I am performing a read using DB file scattered read, or if my file system IO options is set to none by default, I would end up seeing pread 64 calls. Pread 64 call is a blocking IO request. Even here as well, pread 64 calls, we end up reading close to 1 MB. So let me just show you that from that aspect as well. I don't have to basically set file system IO options. All I have to do is set this serial direct read parameter to never to force the session to perform a full table scan using DB file scattered read. So I'm going to do that now in a different session. So let it run again. So if you notice here, guys, I'm basically making pread 64 calls. You have to remember one basic fundamental here. When you are performing a full table scan using DB file scattered read, you are more likely to you are not more likely, you will basically use preread 64 call only, because you are reading the blocks into your buffer cache. Buffer cache. You will not be that aggressive. You will not be that aggressive while bringing the blocks into your buffer cache, because due to the fact that you are reading multiple blocks into your buffer cache, if your buffer cache is incredibly busy, you might end up either invalidating or reusing the existing buffers, or you may even end up notifying the DB writer to write the dirty blocks to the disk. So DB file scattered read always makes use of preread 64 calls. Even though this is a blocking IO request, you end up making large IOs only. You end up making large IOs only. So you have to remember one thing here. If the block is already cached in the buffer cache, this thing will not be 10. You will not read 128 blocks. So suppose if you have blocks such as 1, 2, 3, so on 128, if 64th block is already present in the buffer cache, since DB file scattered read, you end up reading the blocks into your buffer cache. You already have this block in the buffer cache. So Oracle, instead of reading 128 blocks in one IO operation, what it does is it splits the IO into two. It splits the IO operation. These 128 blocks reads into two read requests. So we'll talk about that in tomorrow's session. Right now, all you have to remember is, regardless of whether if it is a direct path read or a DB file scattered read, you end up reading multiple blocks, yes, but the IO operation will be basically reading, making large IO request, because Oracle already knows that the blocks are basically stored adjacent to one another. Due to the fact that they are stored adjacent to one another, Oracle leverages that particular a particular aspect, and then instead of issuing single block reads all the time, it reads the continuous chunk of data in one IO operation. So let me just get back to stuff. So let me just get back to the previous slide. You have to remember, guys, when performing a full table scan using direct path read, Oracle makes use of asynchronous IO calls. Once you submit an IO call, Oracle, instead of waiting, the server process which is performing a full table scan, instead of waiting, what it does is subsequently it will issue another IO request to read another set of blocks or another large IO. So subsequently, you will be issuing the blocks over IO requests over and over again. So the speed of or throughput or the time it takes to perform a full table scan using a direct path read will be very less, because you are avoiding or you are eliminating several sections of the code that involves. I mean, when you are reading, performing a full table scan using a direct DB file scattered read, what you eventually do is you bring the blocks into your buffer cache. So to place a block in the buffer cache, you need to apply a hash function on the DBA or the data block address to find a relevant working set or a hash chain in which it has to be placed. Then you need to find if there are any free blocks in the working set or not. All this stuff you can simply eliminate if you are basically performing a full table scan using direct path read, because you are reading the blocks into your PGA. So there is another thing that you have to remember. There is another fundamental that you have to remember here. We know that all the blocks below the low high watermark position are formatted. So Oracle uses DB file multi-block read count, or the value of this particular parameter to an extent, or it reads the blocks from the extents at the full blown pace, or full pace. It starts reading aggressively till the low high water mark is reached. Once the low high water mark is reached, what it does is it selectively reads only those blocks which are formatted only, because there is no point in reading the blocks which are unformatted. So your IO requests at the tailing section of your SQL trace, or the IO requests at the end, during the end of your full table scan, usually tend to be smaller in size. Instead of reading 1 MB, you may even end up reading only 16 into 8 KB or 32 into 8 KB. So this will be the last IO request at the tailing session of your scan. So this is the basic fundamental as to how Oracle reads a segment header, determines the high water mark, how IO calls are issued, how it issues large IO requests. All these things, these are pretty basic fundamentals. Now we will go even way deeper into stuff. So we'll talk about the plan. I mean, we'll, even before going ahead, let's take a step back and then look at how Oracle even estimates the cost of performing a full table scan. So you have to remember one pretty important point. DB file multi-block read count parameter is a dummy parameter. It is neither used by the optimizer nor used by the session while performing a full table scan. It may sound shocking to you, but it's basically the truth. Neither the session performing a full table scan nor the optimizer uses the DB file multi-block read count parameter. I'll show you in a short while. So how does even Oracle estimate the cost of performing a full table scan? Here, this is the precise formula that Oracle uses. So observe the particular parameter while estimating the cost of performing a full table scan. Oracle always uses DB file optimizer read count parameter value. It's not DB file multi-block read count. You need to understand that basic fundamental. And moreover, Oracle may not even use this particular value if you have system statistics collected, that to MBRC value from your system statistics. If it is present, Oracle uses that MBRC value from the system statistics. It simply ignores the DB file optimizer read count. So this is the basic fundamental. This is how the Oracle, I just want you to understand. M read time, S read time, these are also obtained from the system statistics. If these values are not already populated, Oracle ends up calculating these values using this particular formula. Usually it translates to 26 and then this translates to 12. So do I have to basically, or do you have to basically remember this? No. The only thing that you have to remember here when it comes to how Oracle estimates the cost is the relationship between how DB file multi-block read count, optimizer read count, and MBRC can influence the cost of a full table scan. That we'll discuss now. So even before that, okay, that we'll discuss that, and post that I will talk about MBRC as well. So we'll start with a very basic parameter. We'll talk about the multi-block read count. So Oracle recommends us to not to set a value for this particular parameter. Let Oracle decide on this particular value. Yes, if you do not set it, what would be the value that Oracle can come up with, guys? Is it 128? How many of you agree with this?
Yeah, mostly. Mostly it comes up with the 128.
This is not necessarily true. This 128 is only for systems which have very less SGA or very less number of sessions. So you have to understand, well, I know I've been working in several companies, guys. So in companies like Amazon, you have a sessions parameter set to close to 7,000 or in some cases even 12,000. 4,000 is a minimum value. So here, when your sessions parameter is very high, Oracle automatically reduces this particular DB file multi-block read count. So if you have worked on multiple databases till now, and if you want to truly experience how performance tuning works, you need to work on databases where you have at least 4,000 sessions connected to the database. Otherwise, that database is basically a dummy database. That's what I would say. So you might disagree, but that is exactly how these are the places wherein you get to see the true aspects of a particular Oracle database. So we'll deal with this soon. So Oracle recommends us to not to set the value of this particular parameter. Yes, Oracle recommends us not to set, and moreover, let Oracle determine the value of this parameter. You have to remember this value is calculated during the instance startup. When the instance is starting up, it automatically calculates the value of this particular parameter. This parameter value is dependent on various factors such as optimal IO size, database block size. If you have a 16 KB block size table space, you might end up seeing the value set to 64. It also depends upon the size of your buffer cache and the number of sessions as well. So if you are increasing the number of sessions only by 100 or 500, you may not obviously see the difference. If you are increasing it by thousands only, you will see the difference. So let me just show you the fundamental here. So show parameter db file multi-block read count. So my value, Oracle automatically calculated this value to be 128 here. So what I'm going to do is I'm going to reduce the SGA target here. Thereby inherently this will result in reduced buffer cache size as well. So alter system set SGA max size is equal to 400. So it is equal to SP12, finally restart, then finally let's see what value it will come up with. So let it come back. So how was your weekend, guys?
Vishnu.
Going good, Vishnu. Learning good stuff.
So the SGA target here I have set it to 400 bytes. This is insane. So let me do one thing. I should have used create. So what I'm going to do is I'm going to increase it to 400 MB and then start it up. So the SGA size is now 400 MB, guys. Let's see the value of DB file multi-block read count. See here, guys, it's only 63. Oracle does not always compute the value of DB file multi-block read count to 128. It is dependent on several factors. Now, I just showed you an aspect regarding buffer cache size. So now what I'm going to do is I'm going to increase this buffer cache. some value. I mean, does not have to be precise, but to demonstrate, I think this will be more than enough. Show parameter db5 multi-block. So let me know if you need a break, guys. We can talk about some random stuff for 5 minutes, or we can use the time to clear your doubts. If you feel a bit overwhelmed. So if you notice here, guys, the db5 multi-block read count value is 18. Can you notice the value of db5 multi-block read count?
Yeah.
So not only the buffer cache, it is also the number of sessions and also your optimal IO size value as well. See here, I am using a substandard storage. That's the reason why I have this value as 0. So if I am using any substandard storage, if my this optimal IO size is usually set at this SAN layer, guys, you can adjust this value to any value. Even you can set it to 1280 as well. I mean, there are cases where I've seen the value set to 1280 as well. So you have to understand one thing. This Oracle uses this optimal IO size as well while estimating the cost of performing a full table scan. Sorry guys. It considers the optimal IO size while calculating the value of DB file multi-block read count during the instance startup. So Oracle automatically does not always come up with 128. So if you are thinking that it will come up with 128 value always, it is not true. So you have to remember also another fundamental here. If you have caching at the SAN layer, or even if you are using a substandard storage, even a database restart can trigger a change in the value. That also you need to remember. Even a database restart can trigger a change in the value. So this happens typically very rarely. That too, if you are using substandard, if you are messing up, if the ESXi guys have messed up with few parameters, this is when you actually come up with. I mean, optimizer can, even Oracle can come up with a different dial as well. And you also have to remember, guys, it does not necessarily be 128 always. It can be greater than 128 also at times, and it can also be less than 128. It will not always result in 128. I just shown you how it is related with several other factors as well. It is calculated during the instance startup, and the value persists till the database is restarted. So if you are having non-standard environments or caching at the storage layer, a database restart can trigger a change in the value. So that also you need to remember. This happens pretty rarely. So now we'll dig even a bit deeper, or we'll look in depth regarding why I call this DB5 multi-block read count as a dummy parameter. You have to remember one basic fundamental, or the value or this particular parameter is neither used by the session or the optimizer while estimating the cost or performing a full table scan. Oracle uses the value of DB file optimizer read count for estimating the cost. We'll first start looking at from the cost perspective, then we will go ahead with the reading part. First, we'll just look at the cost part itself, then we'll proceed ahead. So this parameter is indirectly linked to these two hidden parameters, DB file EXEC read count and DB file optimizer read count. So if you do not set the value of DB file multi-block read count and if Oracle is automatically calculating the value of this particular parameter, by default, Oracle always sets the DB file optimizer read count parameter to 8. So when estimating the cost of full table scan, it will always assume the multi-block read count as 8 only. So let me just show you that. So I have this query here. Let me just flush the buffer cache and the share pool. So this is my SPID. I'm going to run an OPT trace, optimizer trace on this particular section. Select ABGR, mark down from students. A minute case. 1 moment. So I am back. I just heard some noise was coming up. So guys, I've just executed this query here. Let us see the cost of this particular full table scan. How much Oracle did estimate the cost of performing a full table scan here. So if you notice here, Oracle did estimate the cost of performing a full table scan to be somewhere close to 66,000. So you need to, there is an important relationship between DB file multi-block read count and optimizer read count. If Oracle is automatically determining the value, then Oracle automatically sets the value of DB file optimizer read count to 8. Suppose if you are manually setting the value for DB file multi-block read count, Oracle will automatically set the same value for optimizer read count as well. It is, this particular fundamental is very important for you guys. So now what I'm going to do is, in the same session, I'm going to set alter system set. So here guys, alter system. What is the multi-block read count value guys here? Multi-block read count value is 18. I'm going to set the same value to 18 here. So even before that, let me show you what typically happens. So what is the actual value for optimizer read count? Oracle automatically set the value to 8. So if I set the value, of this parameter to any other value, whatever it may be, either it is 128 or 16 or whatever it may be, Oracle automatically sets the value to that. Oracle automatically makes sure this parameter also equals the same value. You get it, guys? If you are setting the value of DB file multi-block read count manually, then the same value will be set for optimizer read count as well. So now I have set the value of this parameter to 128. Let me run the same statement again. Before that, let me flush the shared pool and the buffer cache. Let it cache. Unwantedly, I'm flushing the buffer cache. You should not do it on your prod. Just because I have a script, I'm doing it here. So let us see the cost here, guys, for accessing a full table scan. So it should be somewhere around here. So if you notice, guys, do you notice the cost now? Did it increase or decrease, guys?
Decreased, yeah.
Yes, it decreased. So what if I set value of this particular parameter to 8 manually? In this case also, optimizer automatically sets the same value for this parameter. It's as if I haven't set any value for DB file multi-block read count. So now let me execute the same statement. So before that, let me just flush again. I just want you to see the actual thing. That's the primary reason I'm keeping on flushing things out. So I just want you guys to understand the true behavior. See here, guys, what is the actual cost here? So what is the actual cost here? I'll put it here. So you'll see the end of, see the cost here. It is 66,182. It equals, so you get it, guys. Manually setting the value of DB file multi-block read count, you are indirectly changing or affecting the value of DB file optimizer read count. This value is used for estimating the cost of full table scan. So if Oracle automatically determines the value of DB file multi-block read count to 128, in that case, if you are allowing Oracle to determine, in that case, Oracle automatically sets the value of this particular parameter to 8. So manually setting 128 for DB file multi-block read count, Oracle will automatically set this value here. So due to that particular fact, the cost of your full table scan decreases considerably. Oracle automatically determining the value of 128 and you setting the value of this particular parameter to 128, it's not the same. You are influencing the optimizer cost estimates significantly. That factor you need to remember. So can I proceed ahead, guys? Do you have any doubts?
No, Vishnu. It's good.
So there is another important relationship that you have to remember. In the presence of system statistics, if you have system statistics present, Oracle will simply ignore the value of, if you have your system statistics, that to MBRC value, Oracle will simply ignore this particular parameter. While estimating the cost of full table scan, Oracle will simply ignore this particular parameter. You have to remember that. So let me collect. So this, let me set a value so that, to some value and then show you the things and then we'll proceed ahead with the system statistics part. So I'm going to set the value to suppose say 16. So now I'm setting this value to 8, DB file multi-block read count to 8. Sorry guys, I need my session here. So I'm going to set this value to 8 manually here. So let me execute the same query, and before that let me start tracing this again. So this window has become too huge. So what I'm going to do now is I'm going to open a different window and then run a trace here. So I'm going to use the same query as before. I'm going to use the same query as before, and now let's see the cost. Let's see the cost here. See, the cost is, okay, I don't need the entire thing out, I just need this. I just want the window to be as small as possible so that I can fill more details here. So now what I'm going to do is, in the same session, I'm going to set this value to 128. Let me flush everything out. So I'll execute the same query here. Now let's look at the trace file again. Let's see the cost for performing a full table scan. So here I have the explain plan. I basically performed a full table scan here. Let me show you the cost as well. So is the cost same, guys? Is the cost same?
Yes.
So what I'm going to do now is I'm going to reset this particular parameter. Out of system reset db file multi-block read count. So all the examples what I've shown till now is here I'm setting the value of db file multi-block read count. This inherently, when I'm manually setting this, db file optimizer read count automatically assumes this particular value. So I'm just trying to show you how, in the presence of system statistics, Oracle simply ignores the db file optimizer read count parameter. So now the database is restarted. So let's see the value what Oracle has come up with. I think it should be 18. Yes, due to the fact that I've increased the sessions value before. So here I'm going to run the same SQL trace again. For the optimizer trace, I'm going to execute the same query here again. Let's see the cost. So where is the cost part? I have the cost part here. So let me just take a screenshot of this. So I don't have any other details down the tail section. So if you notice here, guys, it automatically assumes the same value because it is using MBRC from the system statistics. MBRC value from the system statistics. So now let's talk about, we are talking just about the cost part, guys. Then we'll talk about db file exec read count. So we are talking about the cost part alone here. So let's talk about system statistics. How many of you here actually think that system statistics is mandatory or system statistics is optional? So Oracle's way or approach in gathering the system statistics is not accurate. I'll tell you precisely why. Because you gather the system statistics when a certain load is running that may not truly represent the hardware characteristics. So what I'm going to do now is I have a table here which is already created. I have a table here called system stats which is already created. It has nothing but 3 columns. I'm going to run a load against this particular table. So even before that, let me just create the reset ST file. I mean, I have increased the sessions parameter and everything. I just want to remove all those changes now. So in the meanwhile, let me run 3 other vertical commands. So, I don't want this reset engine to be present. One moment, yes, I don't want to repeat this activity over and over again. Okay, now it's done. We have a table here table here, which is of the size of 2 gigs. What I'm going to do now is I'm going to run a load on the database, which randomly runs whether either a full table scan or an index scan. So we'll let it run. So give me a minute here. Let me start the workload on the database. So a.run system statistics a.run index load, and then okay, it's starting now. So it is not running that particular thing, it is running some other thing. So see here guys, I'm running a load against the database right now. See, I have 5 sessions which are running DB file, close to 4 or 5 sessions which are running a full table scan, and a few other sessions which are basically doing an index range scan. So let me just show you the plan as well. So this is an index unique scan, and this statement is running with full table scan. So what I'm doing is I'm running a certain workload on the database right now. So now I'm gonna stop the workload on the database. Let it stop. Let it finish executing. Yes, it is stopped. I'll stop the system statistics gather system stats procedure. See here, guys. What is the computed value for MBRC, guys? Is this an accurate value? Does this truly represent my hardware capability?
No.
Now, I'm going to run a different workload here, which basically runs all index related scans. This thing basically runs index scans only. So let me run that. So I have everything which is basically running index scans only. I'm accessing the table using an index unique scan only. All of the scans are index unique scans. Now, what I'm going to do is I'm going to start a different load again here. I'm going to increase the number of sessions. So the results manager kicked in. I don't want this screwing up our results. So I'm doing more full table scans here. Okay, that is all right. Now I'm going to stop the thing, and I'm going to stop the system statistics gathering as well. I don't want to type the entire thing over and over again. So here, if you notice, I'm going to place the values close to one another. So every time for a full table scan, every time MBRC are used. Was there a variation here, guys? Hello? Can you
Yep.
see the variation?
Yep.
So does this truly depict my hardware capabilities? So I'm going to show in a different way here. I have the students table also. So let them finish off. So what is the cost here guys that Oracle used? It's 66,000. Sometimes you will even end up seeing a value 1 here. So do not gather system statistics. Gather system, the point you need to remember regarding all of this is gather system statistics only if you have a representative workload running on the database. Oracle's way of gathering system statistics is or does not represent the true hardware capabilities. Does not truly represent the true hardware capabilities. So gather system statistics only if your workload is representative or if you have an optimal workload running on your database. Only in those cases gather system statistics. Do not gather it. And moreover, if you have shared environments wherein your I/O performance characteristics changes over time or changes during certain times of your day, do not gather system statistics. These values may not be accurate for during that particular point of time. There are also several Metalink documents that suggest every time should be equal to 128 star yes read time. I don't know which guy actually came up with this. This is basically completely wrong. Yes read time, single block. I mean, if you are accessing a single block, how much amount of time it has taken? Multiple blocks, how much time it takes? It is not necessarily 128. You cannot assume DB file multi-block read count to be 128 always. And moreover, a single I/O request, you are reading 128 or how many number of blocks in a single operation, single large I/O operation. That too, the data is contiguous on your disk, and if your disks have something called read ahead switched on, the performance of reading large chunks of data will be good. So let me just show you that as well. Whether read ahead is turned on or not. If your read ahead is turned on, so what I mean, this is a virtualized environment here, so this is the reason why you don't you see missing bad data. So you need to remember that if you have read ahead turned on, so the disk controllers or the what do you call, every disk has a controller inside. So they read ahead on, if you turn it on, at certain times they predict that these blocks, I mean certain number of blocks, adjacent blocks will be read, and it will basically end up reading even before or bringing those blocks into your disk caches even before you initiate an IO request. So the thing is, don't assume this thing, this particular fundamental. If you have really looked at the IO storage part and everything, this memory time is never equals 128. I don't know which actual guy came up with this, but don't do this. So these are the one thing is, do not gather the system statistics only if you have a dedicated hardware running on your dedicated hardware which gives you the same throughput and the workload is same. Only then gather system statistics. In Exadata, things are way different. They have tweaked this MBRC value to make sure that Oracle estimates the cost of performing a full table scan to be very low. to basically force it to go with a full table scan so that cell uploading everything comes into the picture. Exadata system statistics are mandatory due to the architectural differences. So this is one point. Another thing, if you have a database environment wherein the workload pattern changes over time, suppose say in the morning you will be running OLTP workload, and in the evening you will run a mix of OLTP and then a mix of reporting, and then in the evening you will run all data warehouse jobs, wherein data warehouse jobs are basically reports. In these cases, setting the system or scheduling a job which sets the system statistics manually will help. It's not can also, it will help because while performing OLTP workloads, your system statistics may not be representative or will not do good with database warehouse workloads. So warehouse workloads, the system statistics gathered during warehouse workloads may not or will not be good for OLTP workloads. So if you have a mix of that, then gather system statistics. So the point that you have to remember, don't gather system statistics until it is mandatory, or if you have a dedicated working environments wherein your workload patterns are the same, and moreover you do not have a shared environments. And 99% of the time most people have shared environments, and do not blindly think that M read time equals to 128 times the S read time. This is basically fundamentally wrong. People, if you assume this, people will laugh from the storage end. So do not do that. So now, from the cost perspective, we have looked at DB file optimizer, read count, MBRC, and everything. So, shall we proceed ahead with how the read operation regarding the read, guys?
Shall we take 10 minutes break?
Yeah, sure.
Yeah, 10 minutes break will be.
Is it too much?
No, just started kicking in.
I mean, we have not even completed regarding full table scan. I'm just sitting at the 15th slide. We have 50 slides to cover. Hopefully by tomorrow we'll complete the full table scan part, and starting Monday we'll work with we'll start indexing. I think probably in 2 weeks we'll complete off all the indexing types of indexes, cases wherein you end up reading multiple blocks, everything will complete in just 2 weeks alone. Post which we'll start with the joins complete with this. Then we, even before joins, we'll talk about events. Events hardly 4 days. We'll cover at least 5 or 7, 6 events a day. We'll try to finish this course off by August 4th or August 10th. Let's see if people can cope up with the content. We'll finish it in a month, otherwise we'll finish it in 45 days.
Vishnu, how you are loading the data? Is there using any tool for loading the data?
So Jay, you are saying something? I could not hear.
Yeah, how you are loading the data using any swing?
Can you ping? I mean, your voice is not clear, Paul.
So Vishnu, during the weekday also we have 2 batches, morning and evening.
Weekends, this is only practice days. I just want to see the first 2 sessions, how much you can cope up. I mean, are you able to feed or take in more information? And that's just for testing purpose. Then you can sleep for 4 hours straight or not. Not something like that. I just want to use it for the future sessions.
No, no, but but weekday batches will also be there at two batches. Like in the morning,
No,
also
no,
you'll be
only one
conducting a
batch.
batch, and
No, no, one batch.
what? One
Only
batch,
one.
okay.
Yeah, only one batch. That is for practice purpose only. Let others decide.
Hi Vishnu, this is Rakesh.
Yeah, Rakesh.
Vishnu, in high when we dump the header dump of a table, there is a name called map. In our environment, which you have given, it is showing 0 into 0, 0, 0. I just saw in real-time environment, it is showing value. So what exactly it represents?
Extent map. Where exactly?
When you dump here
Just
for high water work,
so one moment. Header blog students more.
yeah.
One more. Yeah, let us take this here. Where exactly?
Here only. There is after last map and will be something like last map and map block. What is that exactly?
Map block. Even I don't know. I mean, we
Okay.
need to consult or we need to raise an SR.
Okay. No, just I was seeing in my real time so I saw some value over there. So
Could be,
I was just curious to know.
could be some value. Even I am not sure.
Is it an extent or anything? I mean, I was thinking like that, so I thought of asking you.
Not an extra thing. It could be some
Okay.
other thing. I don't know. I mean, I didn't dig more deeper. I mean, I found it at a certain level. We need to give up.
Okay.
Beyond that, the other thing I suggest you guys is don't dig too deeper into Oracle. I mean, the market, one thing is every feature out there has certain amount of undeveloped sections of the code. Even during a full table scan, you would end up seeing, I mean, there are many scenarios I'll show wherein it ends up reading only one block at a time, which is quite ridiculous. Even though the blocks are stored adjacent to each other, this entire fundamental what I've told does not make sense in certain environments. So you need to be very careful when dealing with multi-block size table spaces as well. That I will show you. So there are several sections of the code they haven't developed it. I mean, I don't want you guys to dig more deeper. More deeper you dig, more frustrated you get because you find things are not optimal as they should be. So to a certain level, it's okay, beyond that, it does not make sense. And moreover, the market fundamentals these days, warrant you to learn several technologies as well, right? So I think the fundamentals that I'm teaching you are more than enough, or use this as a starting point to, take it even further beyond. But eventually, the points that you get out of it will be very less. Very less in the sense the points are very, I mean, vague at certain times. I mean, they don't even, the amount of time that you spend sitting on it may not be worth it. So what do you think of the economy, guys? a small break for the next 4 minutes. So I just want to see your perception on the view or view on the economy. What do you think is going on? So another thing, during the practice sessions, I'll be loading the data and I'll be giving you the scenarios. So you don't have to deal with loading the data and all those things. That does not make sense. So I'll be creating the scenarios for you. You have to go run the SQL trace if necessary, see the plan, see what is going on. It is mainly focused towards how you troubleshoot the issues. I mean, it's more of training you on how to approach a performance tuning issue. So basically, learning the fundamentals, it's more like, US guys, you might probably know. So it's more like reading a driver's manual, not license exam, right? Do you know? I mean, probably you have taken the lessons, usually not. So it's more like that. So until unless you basically practice, you don't know that much. So another thing I would like to add, guys, the blocks, this particular section may not be up to date at times. You have to remember that. So this particular section, blocks below, especially with the low high water mark, that information may not be up to date and it will be up to date only at certain times. I mean, once you gather the statistics, it tends to be updated. Sometimes it won't show the accurate details. And another thing, I mean, let's see how many of you will come up with a perfect answer. So when I run a query against a particular table, so suppose I select star from students, do you think I read the entire data? I mean,
No.
does the
No,
complete
No.
execution?
no.
So what do you think might be the reason?
It depends upon the buffer cache size.
No, I am talking about full table scan. Buffer cache,
No, it will get the details from segment itself, right, Vishnu?
it will get the details from.
Segment itself instead of waiting.
No, it will execute the query. So select executing, right? So select, I have a students table, select star from students. Do you think the application running this query will, I mean, is it complete? It won't complete.
It will lead the formatted blocks.
Okay?
Formatted blocks.
Formatted blocks. No. What I'm trying to say is if the table size is 2 gigabytes, the entire 2 gigabytes data is there for the entire 2 gigabytes. Do you think a session using full table scan will read the entire 2 GB for migration?
No, I don't think it will.
It's not necessarily the case. So I'll show all these things later on. So Pawan, you are saying something. What do you think would be the reason?
It depends upon actually the number of blocks we are doing.
So can you ping? I mean, your voice is very, it goes often. Hello? Session will not read the full data. Who will read the data?
That's not enough food. Try putting a piece on it. That's not enough food.
So I'm going to show you a simple example now. I mean, just this is nothing related to the normal stuff that we are doing here. So let me show you the simple thing here. So basically, I'm executing a SQL statement against the database. It is performing a full table scan against the database. But how many block reads it is doing? It is hardly reading 480 blocks. What do you think might be the reason, guys? So I'll make it even more weird. So I'll make it even more weird so that you get to see the fundamentals more clearly. So I'm running a different load right now. The same SQL statement. How many blocks it is reading, guys? 506 blocks. See the executions, it is completing. The execution is completing. How many times have I executed the blocks? SQL statement? I've executed more than 6,000 times. I've executed more than 6,000 times, but on an average, I'm reading only 500 blocks. Why do you think would be the reason? And moreover, let me see the query also. I'll show you the query also. It's basically select star from students. Students table, I mean, just before a few minutes, we have allocated a 5 GB extent. So the data is almost close to 224K blocks has data. So here, why do you think it's reading only 500 blocks? Any guesses? Pawan? Okay, your microphone does not appear to work, man. So it's basically, you need to understand one basic fundamental here. Executing a query, application session executing a query does not necessarily mean it will run to completion. I mean, it can halt the execution whenever I want. If they close the cursor from the application end, basically your execution is marked as complete here. It does not necessarily mean, see here, it is reading only 50,000 blocks, 50,000 rows only. For execution, on an average, it is reading only by 50,000 executions. So the first thing you need to remember is executing a query from the application end does not necessarily mean that you read the entire data. You read the entire data only if the application session decides to accept the entire data in the course of certain time. If it thinks that okay, 1,000 rows or 50,000 rows is enough, I think it can close the cursor. If it closes the cursor, basically in that case your execution will be marked as complete. So this is these are all several things that we'll be talking in the future. So let's proceed ahead, guys. I think the break is more than enough. So let's.
Hello, Vishnu.
Yes.
So are we speaking about the optimizer mode? So
Yeah,
something like
optimizer mode has nothing to do with optimizer mode is silly. It has nothing to do with it.
no, even when in optimizer mode, instead of keeping all rows, first rows if you keep around 50 or 100 rows, it will be reading only 100 rows, right?
No, that is wrong. Optimizer mode, when you set it to first rows of 100, it
Yeah.
does not mean that you read only 100 rows. You are basically telling the optimizer that prepare a plan that gets me the first 25 rows as fast as possible. It does not necessarily mean that the SQL execution only reads 500 rows. So let me just show you that as well. People usually get confused with the concept. So I have the database here. So we will select alter system set optimizer mode. We got the first rows of 10. Optimizer mode is equal to first rows optimizer mode is equal to first rows of 10. Okay, 10 or 19, whatever the value is. So okay, it takes only these things. Okay, I'll take 10 value here. C.Z.D.ZDR. So I have set the value of optimizer mode to first rows of 10. So what is the user here? Your user is Vishnu. Select mark 1, common count of star from students. Group by mark 1. So how many rows I am getting here, guys? Can you notice? I got 1600 rows. Suppose if I use select star from students, regardless of that, I end up retrieving the data. So the optimizer mode, the first rows is completely different than whatever people think is wrong. That is completely wrong approach. I mean, that is basically due to the fact that you might have gone or read some books or blogs which are completely shit. So we'll proceed ahead, guys. I mean, I don't want to waste time here. So as we complete, I mean, there are only 2 more slides. I mean, how many? Let me just bring up the slides here. We just have just 3 more slides, and we can wind up this session today. So morning session, we had so many doubts. So let's talk from the read perspective, guys. When you are performing a full table scan, you do not necessarily read the number of blocks. I mean, a session will not use the value of this particular parameter. A session always uses the value of this particular parameter while performing a full table scan. Do not assume that DB file multi-block value is used. So Oracle uses this particular value only. DB file, I mean the session which is performing a full table scan always uses DB file exec read count value only, regardless of the value of this particular parameter. But you need to remember that regardless of whether you are allowing the Oracle to determine the value of DB file multi-block read count either automatically or by if you set it manually also, Oracle will ensure that DB file exec read count will take the same parameter, will take the same value. So let me just show you that as well. So let me just close everything off and show you this. So DB5 exec read count is 128. So Oracle will make sure that DB file this parameter DB file exec read count is equal to DB file multi-block read count. So I'm going to set the value of this particular parameter to suppose say 123. In this case also, Oracle will make sure DB file exec read count will assume the same value only. So let me show you that in practice right now. So let me just set. So alter system set DB file multi-block read count is equal to 128. I'll open up a different session and here let me show you a query first. I'm going to run what the hell, guys. I'm still running some load on the database. I just want to quit all these things. Let's see if my load is decreasing. Yep, I think the load has come down. So now what I'm going to do is I'm going to run an SQL trace on this particular session. And I'm running SQL query. How many blocks it is reading? 128 blocks in one IO operation. So alter session set db file exec read count is equal to suppose say 32. So if I execute the same query, how many blocks it is reading, guys? 32 blocks. So you have to remember a session performing a full table scan will always use the value of db file exec read count. It's not db file multi-block read count. So anyhow, Oracle, regardless of whether you set manually or Oracle automatically determining, Oracle will set the same value for this, but you need to remember that this parameter is not used. If you are thinking that db file multi-block read count is used, it is not used. It is basically this particular parameter that is used internally. So let's proceed ahead with the next slide. I've already shown you guys. I've already shown you that. Let me should go with the next slide here. So due to the relationship you have with db file multi-block read count and optimizer read count, setting the multi-block read count to 128 manually, you are reducing the cost of full table scan. Don't assume that. I've shown you this. Do you remember, guys? Hello? Just a while back, I just showed you.
Yeah, Vishnu.
This is the basic fundamental that you have to remember. And another thing, the number of the IO size, it translates to 1 MB may not necessarily be true. It is basically dependent on several factors. So this can be greater at times as well, rarely due to the optimal IO size. Just because you saw only a few scenarios wherein it is only 1 MB does not necessarily mean that it always translates to 1 MB. I had a custom storage server wherein I increased the optimal IO size considerably and then changed session parameters. This db file multi-block read count Oracle even automatically calculated the value to be 136 also at times. So 99.9% of the time it usually translates to 1 MB, but does not necessarily mean, or you cannot say that as a universal truth. And also when it comes to table spaces with multiple block sizes, things differ consistently or things differ completely altogether. So we'll talk about this in the further sessions. Probably tomorrow we'll talk about this. So now that we have seen how the session performs a full table scan and what parameters are actually come into the picture and what all factors influence the cost in determining the cost for a full table scan, now let's just talk about how a session performs a full table scan. So you have to remember optimizer's duty is to just come up with the plan. Its duty is to just come up with the plan. That's it, nothing else. It's the session which actually decides whether to perform a full table scan using direct path read or scattered read. Sorry, direct path read or scattered read. It's the session which actually decides it. So there are various factors that actually come into the picture in the decision process, whether to go with DB file scattered read or direct path read. So we'll talk about more all of those in the coming sessions. So for now, the basic thing that you have to remember is DB file scattered read is a buffered read operation. You will always end up using preread 64 calls, which are synchronous calls. You will end up waiting till that particular IO request is complete. So if you are performing a full table scan, and if Oracle Optimizer ended up selecting DB file scattered read due to bad statistics or some other thing, you would essentially flood the buffer cache with the blocks. But flooding the buffer cache does not necessarily mean it affects other sessions. We'll talk about those when we are dealing with buffer caches as well. So usually people think that when you are flooding the buffer cache, I mean, while performing a full table scan using a DB file scattered read, you end up flooding the buffer cache with blocks. But this may not be necessarily true. If your blocks in the buffer cache are sufficiently hot enough, it won't even have a marginal impact also, that you need to remember. So DB file scattered read brings blocks into your buffer cache. So direct path read, you are skipping all these layers. You just directly read the data into your PGA itself. You don't read the data into your buffer cache. You just read the data into your PGA directly from the disk. Minimal effect on buffer cache, basically very minimal effort. So how many of you think that direct path read operation, I mean, are there any chances that direct path read can bring blocks into the buffer cache, guys?
No.
Yeah, it can, it will bring. So we'll discuss about that tomorrow. It will have a minimal effect on the buffer cache. That's the reason why I said it has the capability to bring blocks into the buffer cache indirectly, not directly. We'll talk about that. So asynchronous IO, it primarily makes use of asynchronous IO. Since you are basically reading from the disk directly into a PGA, you want to complete it as fast as possible. So Oracle leverages that particular fact and then starts using asynchronous IO.
Vishnu, what you're saying, direct path read. I was thinking if data is modified, then in that case, it will read from buffer cache, right?
Even in that case, if the data is modified also, the table data it will never bring into the buffer cache. Even you are reading using direct path read, it will not even bring the data. So, and Pawan was saying some awkward behavior regarding select generates redo. No, it has nothing to do with that. I mean, that is a silly thing. Select generating redo is basically due to commit cleanout. Commit cleanout, or even if you have auditing, you will end up generating redo. And in some other cases, cleaning up ITL records is one thing. You will end up seeing 4 or 5 scenarios case over the course of this session. So that's not it as well. So we'll talk about those slowly. So direct path read makes use of asynchronous IO to the full extent. So file system, if your data files are placed on the file system, make sure that file system IO options is set to set all. We'll talk about all these things, all the file system IO options, all these parameters on page cache, how it is related, everything tomorrow. Because I want both the classes to be consistent with each other. So It makes use of IO request, IO submit calls, and you have to remember, guys, direct path read, due to the fact that you are reading the blocks directly from the disk. So in an RDBMS, I'm not okay, just I don't want to go into that detail, so just putting it in a different way. The buffer cache can have dirty blocks in it. Buffer cache, I mean, a database can have dirty blocks in its buffer cache. So the dirty blocks can have the latest data. So if you are directly reading from the disk, you may end up reading old data. So that is the reason why Oracle ends up performing an object level checkpoint before it starts performing a full table scan using a direct path read. There are certain side effects that come due to this. I mean, this feature is good, but it does have its side effects. It does have its fair share of side effects that we'll be discussing slowly as well. So these are all pretty simple stuff, guys. We'll talk about many of these in detail in the coming sessions. Just made it even intense compared to the first batch. So here, serial direct read, guys. And moving on to the next phase. I mean, I just told you regarding the basic fundamental difference between a scattered read and a buffered read. So serial direct read. Serial direct read parameter is more like a master switch. When it comes to a session deciding whether to perform a full table scan using DB file scattered read or direct path read, the default value is auto. Auto means use cost-based approach. Auto means use cost-based approach. So you can set the value of this parameter to true or always. When you set this value of this parameter to true or always, Oracle will always make sure that it performs a full table scan or an index scan, fast full index scan using direct path read only. You are forcing the session to perform full table scan using direct path read only. If you set the value of this parameter to false or never, Oracle will prevent direct path read. It will always do DB file scattered read. It will always do DB file scattered read. So at a session SQL level, you cannot influence this. You cannot influence this decision process at the SQL level. You can either influence the decision at the session level or at the system level using this parameter alter session or alter system set, but not at the SQL level using this particular hint, OPT params hint. So when you have this parameter set to auto, Oracle uses the cost model. So this parameter applies to both tables and indexes as well. When you are using the cost model, Oracle considers various factors such as size of the table in the blocks, various thresholds such as small table threshold, medium table threshold, very large object threshold. See guys here, small table threshold and medium table threshold. These relates to tables only, not indexes. Very large object threshold, object. See the object here, object threshold. It applies to both tables and indexes also. So, and moreover, it also considers if how many buffers are already cached in the buffer cache, whether if there how many are dirty, how many are clean as well. Considers all these details. So guys, now let's see the two parameters that I was talking about. So here, once you set the value of this parameter, so I don't know why I'm getting a beep here. So when you set the value of parameter db file serial direct read to false Oracle, regardless of the size of the or size of the index, it will always with db file scattered read. If you set this parameter to true, regardless of the table size, it will always end up going with direct path read only. I think it is due to the recording, guys. I'm going to stop the recording. I think the session is